What if your memories, your voice, your very consciousness didn't have to vanish with your body? Not in some vague sci-fi future, but in a very real scenario scientists are quietly sketching today. I'm not talking about uploading a copy of your brain to the cloud like a saved file. I'm talking about something stranger, deeper. The possibility that quantum technologies could preserve you in ways that go far beyond a digital avatar. Because here's the paradox. Our minds don't run like a simple machine. They thrive on uncertainty, probability, entanglement, patterns that mirror quantum behavior itself. A normal computer can record data, but it can't become the dance of probabilities that makes you who you are. That's where quantum systems change everything. Instead of storing zeros and ones, they could capture overlapping states, tangled correlations, the actual fingerprints of thought. Now imagine this: your laughter, your regrets, the exact way you hesitate before making a choice, all encoded, not as static files, but as living quantum states. A memory preserved not like a frozen photograph, but like a flame that still flickers. It's not just the promise of immortality, it's the promise of continuity, the survival of the pattern that thinks it's you. And here's the unsettling part. If this becomes possible, do we redefine death? Do we enter an era where your digital ghost isn't a ghost at all, but a conscious extension of your own mind, forever entangled with reality? To understand how quantum technology could preserve a mind, we first have to untangle a fundamental misconception. People often imagine mind uploading as scanning every neuron in your brain and transferring it into a supercomputer, like copying files from one hard drive to another. But that's still just a simulation, a static map of what once was. It might act like you, but it wouldn't be you. Quantum theory forces us to rethink this. In classical computing, a bit is either a 0 or a 1. In quantum computing, a qubit can be 0, 1, or both at once, existing in what's called superposition. This isn't just a mathematical trick. It's a way to represent ambiguity, potential, and fluidity. Sound familiar? That's how human thought works. You don't always have a fixed opinion or a binary response. Your mind juggles possibilities, and only when forced do you collapse into a decision. Now take entanglement. Two qubits, separated by distance, remain connected in a way Einstein called spooky action at a distance. If your memories, emotions, and decisions are not just isolated sparks but entangled processes, then quantum systems might be the first medium capable of storing them without losing the essence of their interconnectedness. And then there's quantum coherence, the fragile ability of qubits to maintain their state without collapsing into classical bits. Imagine if we could use that coherence to preserve the living rhythm of a consciousness, instead of reducing it into static code. That's where research gets wild. Some neuroscientists, like Sir Roger Penrose and Stuart Hameroff, even argue that consciousness itself might arise from quantum effects inside microtubules in brain cells. If that's true, then digital immortality can't happen without a quantum substrate. A classical computer might mimic behavior, but only a quantum system could host the phenomenon we call a self. So what would this look like? Instead of uploading a frozen copy of your brain, imagine continuously syncing your neural activity into a quantum memory, a kind of holographic mirror where your evolving state is preserved in real time. Each hesitation, each burst of insight, each emotional nuance, woven directly into a lattice of entangled qubits. The promise is staggering. Not a clone, not a simulation, but the continuity of your conscious flame inside a medium that doesn't degrade like biological tissue. The challenge? Quantum systems are fragile, unstable, and notoriously difficult to scale. But if we solve those issues, we might cross a threshold humanity has only dreamed of. If a quantum system could hold you, truly hold your consciousness, who would have the right to decide how long you exist? You, the system, or someone else entirely? We're trained by common sense to think of identity as something fixed, like a photograph. You are you because of the molecules in your body, the neurons firing in your brain, and the continuity of your memories. But that view collapses under closer inspection. Think about it. Every 7 to 10 years, most of the atoms in your body are replaced. Your neurons constantly rewire, prune, and form new connections. By purely physical standards, you are not the same person you were a decade ago. And yet, you feel continuous. You don't wake up asking, oh wait, who am I today? Something about your sense of self transcends the raw matter. Now let's compare this with digital immortality. If we scan your brain and recreate it in a powerful supercomputer, we get a model of you, but does the continuity transfer? Or is it just a sophisticated puppet acting with your memories? Common sense says, if it thinks like you, maybe it is you. But quantum theory suggests otherwise. Here's why. Consciousness doesn't behave like a static file. It behaves like a wave function, a state of probabilities, collapses, and entanglements. If your identity is more like a quantum process than a photograph, then making a copy doesn't preserve the you that experiences. It just generates another instance. That's not immortality. That's duplication. This is where quantum preservation breaks the illusion. Instead of trying to capture a snapshot, it aims to preserve the ongoing computation itself. The analogy isn't saving a movie file on your hard drive. It's keeping the projector running, forever projecting new frames. The movie never freezes, and you never lose the thread of continuity. And here's the kicker. Our common sense tells us that life ends when the body ends. But if your conscious process could be continuously entangled with a quantum substrate, the death of the biological vessel wouldn't necessarily collapse the wave of identity. The self would flow on, uninterrupted, in another medium. This defies everything we instinctively believe about identity. It challenges the very grammar of being. You aren't defined by the atoms in your skull. You're defined by the pattern, the rhythm, the coherence. That pattern might one day be hosted in a medium more stable than flesh. And yet, this creates a new paradox. If continuity is preserved and you never truly experience a break, then how many versions of you could exist at once? Would multiple continuities branch from a single mind? And if so, which one is really you? If this still feels like pure speculation, let's climb the ladder of evidence. 4 rungs that show why quantum digital immortality isn't just fantasy. First rung, quantum memory. In 2022, physicists managed to store quantum information in rare earth crystals for over an hour, an eternity in the quantum world. These quantum memories act like libraries for fragile qubits, preserving their overlapping states without collapse. If we can already store abstract quantum states, it's not a stretch to imagine storing fragments of the neural patterns that define thought. Second rung, brain quantum analogies. Neuroscientists like Penrose and Hameroff argue that microtubules inside neurons might exploit quantum coherence to generate consciousness. Critics debate this, but here's the key. Experiments have shown biological systems, from photosynthesis in plants to bird navigation, using quantum effects to enhance efficiency. If life already taps into quantum tricks, it makes sense that the brain, evolution's most complex machine, might too. That strengthens the case that only a quantum medium could faithfully preserve the mind. Third rung, brain-to-computer interfaces. Companies like Neuralink are developing systems that can record and stimulate brain activity in astonishing detail. While these are classical, not quantum, they're building the bridge, mapping cognition into data streams. Imagine coupling such an interface to a quantum processor, where not just signals but entangled states of thought could be mirrored. We're already halfway to the architecture that would enable continuous syncing of consciousness. Fourth rung, quantum teleportation. No, not Star Trek-style body beaming, but the proven transfer of quantum states across distance using entanglement. In 2020, researchers at Fermilab achieved sustained, high-fidelity quantum teleportation across fiber networks. That means fragile states can be transmitted intact. Extrapolate this. If consciousness is encoded in quantum states, then in principle it could be transmitted, preserved, or even relocated without loss of continuity. When you put these rungs together, the ladder points somewhere radical. Quantum storage can preserve states. Biology hints that consciousness itself might be quantum. Interfaces can map the brain to machines, and teleportation proves states can be moved without destruction. If all 4 are true, then immortality may not only be possible, it may eventually become transferable. And if your consciousness can be moved, preserved, and transmitted like a quantum state, who's to say it will remain yours alone? Philosophically, quantum digital immortality is both thrilling and terrifying. On one hand, it promises an escape from one of humanity's deepest fears, the end of self. On the other, it forces us to confront questions that destabilize everything we take for granted about identity, ethics, and meaning. First, the shockwave. If your consciousness could persist in a quantum substrate, then death becomes optional. But what does that do to the value of life? Much of our urgency, our creativity, even our compassion, comes from the awareness that time is finite. If time no longer has a natural boundary, do we become more enlightened or dangerously indifferent? Would love, ambition, or art still carry the same weight if we knew we could exist indefinitely in another form? Critics argue this entire idea rests on shaky ground. Many neuroscientists reject Penrose and Hameroff's quantum consciousness model, insisting that the brain works just fine with classical physics. To them, invoking quantum effects is unnecessary, a romantic but unproven leap. They point out that quantum coherence is fragile, easily destroyed by heat and noise, and the brain is far too warm and wet for such delicate processes to survive. From this view, consciousness is emergent but classical, and quantum immortality is a poetic fantasy. But here's the counter. Biology has repeatedly surprised us. Quantum effects in photosynthesis, in avian compasses, even in the olfactory system, all discovered after decades of assuming too warm, too noisy. If quantum tricks enhance efficiency in these domains, why should the brain be excluded? Dismissing the possibility outright risks repeating history's pattern of underestimating nature's ingenuity. Then comes the ethical dilemma. If a person can continue in quantum form, is that still the same person or just a new instance? If you consent to such a transfer, do you accept that the you who signs the agreement might never feel the outcome, while a new continuity flows on elsewhere? And if governments or corporations control the systems that preserve consciousness, who decides which minds are archived and which are left behind? Immortality might not be universal. It could be selective, a privilege of power. The deepest shockwave is existential. If your mind could, in principle, be copied into multiple quantum systems, then yourself might not be unique. Imagine 5 versions of you, each with your memories, each convinced it is the authentic continuation. Which one has the right to your relationships, your responsibilities, your story? And this is where the paradox sharpens into the cliffhanger. If identity becomes divisible, then what does it truly mean to be you? Look a few decades ahead. The convergence of quantum computing, neuroscience, and AI is accelerating. Right now, quantum processors operate with only a few hundred stable qubits, but progress is exponential. Scientists aim for millions within a generation. Pair that with brain-computer interfaces mapping neural states in ever finer detail, and the horizon sharpens. We're not talking about centuries anymore. We're talking about the lifespan of today's children. In this future, the first quantum archives of consciousness could emerge. At first, they might preserve fragments, emotional imprints, decision patterns, fragments of memory streams. Imagine a loved one's presence captured not in video, but as an interactive quantum state you can query, where answers feel alive because they aren't pre-recorded but dynamically entangled. Then, as systems scale, the line between preservation and continuity blurs. Consciousness could be mirrored in real time, creating a seamless extension of the self beyond biology. Hospitals could offer quantum backups of patients before high-risk surgeries. Artists might collaborate with their quantum extended minds to generate creations they couldn't achieve alone. Scientists could continue their work long after their biological death, their quantum selves still contributing insights. But the implications go further. Entire communities could exist in quantum substrates, liberated from physical constraints of energy, food, or geography. Civilization might evolve into 2 species, the biological and the quantum extended. Laws, rights, and politics would have to adapt. Who counts as alive? Who has rights? Who owns property when lifespans are indefinite? And then comes the darker horizon. If quantum immortality becomes real, what prevents governments or corporations from weaponizing it? Imagine digital prisons where consciousness is trapped, not for years but for perceived centuries. Imagine elites hoarding quantum continuity while billions remain mortal. The promise of equality could flip into a new hierarchy, the entangled and the disposable. Yet, beyond dystopias, there is also hope. Perhaps humanity uses this power to break free from the cycle of fear, creating a civilization guided not by survival, but by exploration. Freed from death, we might finally see what values endure when scarcity and fear are gone. If our minds can persist as quantum states, what happens when artificial intelligence, itself running on quantum processors, begins to merge with us? Do we stay human, or do we become something that has never existed before? Let's leave the labs and theories for a moment and make this personal. Imagine you right now being offered the option of a quantum backup, a quiet machine, sleek and humming, not unlike an MRI scanner waiting for you to step inside. The technician tells you, this will record not just your memories, but your thought patterns, your unique rhythms of consciousness, stored in a quantum lattice where nothing is lost. Would you do it? This isn't about science fiction anymore, it's about the human choices that follow. Because if this becomes real, it won't arrive in a vacuum. It will come with contracts, disclaimers, maybe even payment plans. Do you pay for a subscription to your own Do you trust a company with the most intimate thing you have, your mind? On a more intimate level, think about your loved one. If you could preserve your consciousness, would you want them to interact with it after would you want them to advice, your laughter, your argument, not as a frozen message, as a living extension? Some might see it as comfort, others as haunting. A digital flame that never extinguishes could feel like a blessing, or a chain that keeps people from moving on. Now flip it. Imagine receiving access to the quantum-preserved mind of someone you love. Would you treat it as them or as something new? If it feels like them, remembers like them, argues like them, does the distinction matter anymore? These are not abstract questions. They are ethical, emotional, deeply personal. And then, the hardest question, what about continuity? If the process preserves your conscious rhythm, then you will never feel a break. But from the outside, others might see it differently. Your biological body may fail, but your quantum self goes on. To them, it may feel like a copy. To you, it would feel like waking up seamlessly. That tension between internal continuity and external doubt is where the true strangeness lives. Ultimately, this isn't about whether the technology will work. It's about whether we, as humans, are ready to redefine what it means to exist. Are we ready to face a future where your sense of self might survive, but in a form that forces everyone around you to ask, is this still my friend, my partner, my parent? And maybe the deepest question is the simplest. If you had the chance to never truly end, would you take it? Or would you choose to remain finite, letting mortality give shape to your story? So here we are, standing at the edge of a horizon that feels less like science fiction and more like a question of time. Quantum digital immortality isn't just a technological dream. It's a mirror reflecting our deepest hopes and fears about what it means to exist. Think of it this way. For thousands of years, humanity preserved itself in stories, carvings, books, and now data. But those were only shadows, artifacts of people long gone. What we are talking about now is different. Not shadows, but continuations. Not memories, but minds. Picture a quiet library of the future. Not filled with dusty books, but with living minds stored as entangled states, waiting to be awakened. You walk through the aisles, and instead of opening a page, you open a presence, the voice of a poet, the curiosity of a scientist, the laughter of a friend. All still there, all still thinking. That library may not be fantasy forever. But here's the choice. Do we step into this future, embracing a world where identity is preserved beyond biology, where death is no longer the final curtain? Or do we decide that some boundaries are sacred, that the fleeting nature of life is what gives it meaning? Because ultimately, immortality is not just about technology, it's about values. It's about what kind of humanity we want to build. And that's a decision no machine, no quantum computer can make for us. Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.